Have you ever wondered how a tiny speck of gold, hidden deep beneath the Earth's surface, becomes a brilliant gold bar worth thousands of dollars? Gold is one of the rarest and most valuable metals ever discovered. For more than 6,000 years, it has fascinated civilizations across the globe. Ancient kings decorated their crowns with it. Empires built their wealth around it. Today, it is used in jewelry, banking, electronics, medicine, aerospace technology, and even advanced scientific equipment. But before a single gold ring appears in a jewelry store or a gold bar is locked inside a bank vault, the metal must complete an extraordinary journey. It begins hundreds and sometimes thousands of feet below the ground, where tiny particles of gold remain trapped inside solid rock. Recovering this precious metal requires enormous mining equipment, advanced engineering, powerful chemistry, and some of the world's most sophisticated refining technologies. Every year, mining companies move millions of tons of rock to recover only a small amount of gold. In many cases, a single ton of ore contains just a few grams of this valuable metal. Today, we're taking you inside the complete gold production process, from discovering hidden deposits deep underground to mining, crushing, extracting, and refining gold into nearly pure bullion bars. Let's begin the incredible journey of one of nature's greatest treasures. Long before any machines begin digging, years of exploration take place. Finding gold isn't simply a matter of luck. It requires science, experience, and cutting-edge technology. Teams of geologists study satellite images, geological maps, historical mining records, and aerial surveys to identify regions that may contain valuable mineral deposits. Once a promising location is identified, experts travel into the field to collect rock samples and soil samples. These samples are carefully analyzed in laboratories for tiny traces of gold and other valuable minerals. If early results look encouraging, exploration drilling begins. Powerful drilling rigs bore deep into the Earth's crust, extracting long cylinders of rock known as core samples. Each core sample provides valuable information about the underground geology, allowing scientists to estimate the size, depth, and quality of the gold deposit. Interestingly, thousands of exploration projects are conducted every year, but only a very small percentage ever become profitable gold mines. Even after discovering a significant deposit, the work has only just begun. Mining companies often spend several years obtaining environmental approvals, government permits, and mining licenses. Roads must be constructed, electric power lines installed, water supply systems developed, processing plants built, worker accommodations established. Only after years of planning and billions of dollars of investment can commercial gold production finally begin. Once construction is complete, mining operations officially begin. Depending on where the gold deposit is located, mining companies generally use one of two methods. The first is open pit mining. When gold ore lies close to the Earth's surface, massive open pits are excavated. These mines can stretch for several kilometers across and hundreds of meters deep. Gigantic hydraulic excavators remove layer after layer of rock, while enormous haul trucks transport the ore to nearby processing plants. Some of these mining trucks carry more than 400 tons of material in a single load. Standing beside one is like standing next to a two-story building. Every day, dozens of these giant machines operate around the clock to keep production moving. However, not all gold deposits are located near the surface. Many are buried much deeper underground. In those cases, underground mining becomes necessary. Engineers construct vertical shafts and horizontal tunnels that extend hundreds or even thousands of meters below the surface. Specialized drilling machines bore into the rock. Controlled explosions carefully break apart the ore. Heavy-duty loaders collect the broken material and transport it back to the surface using underground trucks or conveyor systems. Underground mining is more complex, more expensive, and often more dangerous than open-pit mining, but it allows access to rich deposits that would otherwise remain unreachable. Despite the enormous amount of rock being mined, the actual gold content is surprisingly small. In many operations, one entire ton of ore contains only 2 to 5 grams of gold. That means mining companies must process enormous quantities of rock just to recover a relatively small amount of precious metal.
Once the ore reaches the processing plant, the next stage begins. Large rocks are far too big for gold extraction, so they must first be crushed into much smaller pieces. The ore enters powerful jaw crushers, where massive steel plates squeeze the rocks until they fracture. From there, the material passes into cone crushers that reduce the rock to even smaller sizes. Although the rocks are now much smaller, the gold particles remain trapped inside the surrounding minerals. To release them, the crushed ore moves into enormous rotating grinding mills. These giant cylindrical mills slowly rotate while thousands of heavy steel balls tumble inside. As the balls collide with the ore, the rocks are gradually ground into an extremely fine powder. This process may continue for several hours until the particles become almost as fine as flour. Grinding is one of the most critical steps in gold production. The finer the ore becomes, the easier it is to expose the microscopic gold particles hidden within the rock. Without this stage, much of the gold would remain locked inside the ore and be impossible to recover efficiently. Finally, the powdered ore is mixed with water to create a thick slurry. This slurry can now move easily through pipelines and processing tanks, preparing it for the extraction stage. Now comes the stage where the hidden gold finally begins separating from the surrounding rock. Depending on the characteristics of the ore, mining companies may use several different recovery methods. The first is gravity separation. Gold is one of the densest naturally occurring metals on Earth. Because it is much heavier than most surrounding minerals, specialized equipment can separate larger gold particles using gravity alone. Machines such as shaking tables, spiral concentrators, and centrifugal separators spin or vibrate the material, allowing the heavy gold particles to settle while lighter waste minerals are carried away. Although gravity separation works very well for coarse gold, it cannot recover the tiny microscopic particles found in most modern gold deposits. For those particles, a different method is required. The most widely used technique is cyanide leaching. Inside enormous processing tanks, the powdered ore slurry is mixed with a carefully controlled cyanide solution. Oxygen is introduced into the tanks, while giant mechanical agitators continuously stir the mixture. Under these controlled conditions, the cyanide reacts with the microscopic gold particles, dissolving them into the liquid while leaving most of the surrounding minerals untouched. Although cyanide has a dangerous reputation, modern gold mines operate under strict environmental and safety regulations. Advanced containment systems, monitoring equipment, and recycling technologies help ensure that the chemical is safely managed throughout the extraction process. After the gold has dissolved into the cyanide solution, the next challenge is recovering it in a concentrated form. One of the most widely used methods is called the carbon in pulp, or CIP process. Large tanks are filled with activated carbon, an extraordinary material containing millions of microscopic pores. As the gold-rich solution flows through these tanks, dissolved gold molecules naturally attach themselves to the surface of the carbon. Once the carbon has absorbed enough gold, it is removed from the tanks and washed to eliminate unwanted impurities. It is then transferred to a stripping circuit, where heat and chemical solutions separate the gold from the carbon. The cleaned carbon can be reused many times, making the process both efficient and economical. The concentrated gold solution is then sent to the next stage, electrowinning. In this process, an electric current passes through the gold-bearing solution. Positively charged gold ions move toward negatively charged metal plates called cathodes. Over time, a thick layer of metallic gold builds up on these plates. Once enough gold has accumulated, the plates are removed and the precious metal is carefully scraped off. The result is a highly concentrated gold sludge that contains far more gold than the original ore. This material is now ready for the next major step. Once refining is complete, the pure gold is ready for its final transformation. The metal is melted one last time inside precision furnaces and poured into carefully designed molds. Different molds produce bars of various sizes, ranging from small investment bars weighing just a few grams to large bullion bars weighing approximately 400 troy ounces, or about 12.4 kilograms. After cooling, each gold bar is removed from its mold and thoroughly cleaned. The surface is polished to achieve its distinctive bright finish. Every bar is then weighed using highly accurate digital scales and tested using advanced analytical equipment to verify its exact purity and composition. Finally, important information is permanently stamped onto the surface of each bar. This includes the refinery's official logo, the bar's unique serial number, its weight, and its purity rating. These markings guarantee authenticity and allow every bar to be traced throughout its lifetime. Some of these gold bars are shipped directly to secure bank vaults and bullion dealers. Others are transformed into beautiful jewelry, investment coins, electronic connectors, medical instruments, aerospace components, and countless high-technology products used. Gold mining has changed dramatically over the past few decades. Today's operations rely heavily on automation, robotics, artificial intelligence, GPS-guided drilling systems, drones, and real-time monitoring technology. These innovations improve safety, reduce operating costs, and help mining companies recover more gold while using fewer resources. Environmental protection has also become a major priority. Modern mines recycle large amounts of water, reduce greenhouse gas emissions, improve energy efficiency, and increasingly power their operations with renewable energy sources such as solar and wind. Strict environmental regulations require companies to carefully monitor water quality, air emissions, and waste management throughout the life of the mine. When mining operations eventually come to an end, the work isn't finished. Many companies begin extensive land rehabilitation programs, reshaping the landscape, replacing topsoil, planting native vegetation, and monitoring environmental conditions for many years afterward. The next time you see a piece of gold jewelry or a shining gold bar, you'll know the incredible journey it took to get there. If you enjoyed this inside look at the gold factory process, be sure to like the video, subscribe to the channel, and let us know which manufacturing process you'd like to explore next. Thanks for watching. See you in the next video.